Hey everybody, good morning again. It's Monday, and I've just got news that I'm going to be out at least one more day, so it's today and tomorrow of videos. Hang in there, I'm trying to make as much as I can to keep things moving for you and keep us moving forward. We still have a deadline, we still have time constraints, and hopefully you're surviving. The quiz on Friday looked great, lots of great results, lots of 100%. Definitely it looks like you're improving and working and building skills. So let's keep it going with section 2-3. If you haven't yet done so, please open up your notes to section 2-3. Feel free to, of course, pause the video and then push play when you're ready. Do that anytime during this video. There are some videos on top that are linked that talk about this thing called determining linear equations and proportional relationships. I like both of those videos, but I'm choosing to make something custom here since this is a little unexpected. What I'm going to do is go through the notes with you. I'm going to try to keep it moving, knowing that you can pause and add on to your own notes. As before, you should consider splitting your screen, and here we go. So first and foremost, this idea of proportional relationships are simply relationships that are not only linear, and it says here linear are things that are relationships that have a constant change. So if they're always going up by 3 or down by 2 or up by 7/3, right? Those slopes are indicators of things that are linear. Well, linear relationships can either be proportional or they can be not proportional. We're going to start by talking about the proportional relationships today, and then we'll get to non-proportional relationships tomorrow or on Wednesday. And the key ingredient of proportional relationships are two things. I guess three. First, you can write a pattern in an equation that looks like this. Y equals mx, and m is your slope. So it might be something like y equals 2x, or y equals 5x, or y equals 2/3 x. Any of those things are examples of proportional relationships. Also proportional relationships. Any proportional relationship has 0, 0 in the pattern. So if you imagine, let's say our first equation here, y equals 2x, if I put a 0 in the y spot, and I put a 0 in the x spot, I get 0 equals 0, right? So that's a true statement. So that means that each of these equations, this one, this one, this one, and the generic version, all of them could take 0, 0, put it in the x and the y location, and get a true statement. That means 0, 0 is always part of the pattern. And then finally, if you take any of the y's and divide it by its equivalent x, you're always going to get the slope, which is kind of interesting. That is not the same as what we've been working on. We've been actually working with the concept of change in y over change in x, because that's the more generic way to make this work. But in proportional relationships, you can actually even go easier and just divide the y by the x, and you'll get the slope. It's a good way to check to see if something is proportional. So one more time, you need those three things to take place. You need a y divided by x equals your slope. That's the first item. You need 0, 0 in the pattern, and you need it to be able to be written in that form, y equals mx. We have that piece in the light bulb. All right, here we go. So is the following relationship proportional? And if so, what is the constant of proportionality? That is a super fancy phrase for slope. All right, so make a little note of that. You're going to see the phrase constant of proportionality. That is a fancy way to say slope. We still use the letter M. Some books will use the letter K. We're not going to worry about that. The example, Mr. Wright earns $15 an hour working at Red Robin. All right, simple enough. $15 is the constant. We're going to call that slope. So we know that the slope is already 15. And we recognize that if he doesn't work, he works 0 hours, he's going to get paid $0. So that makes complete sense to us. We would say therefore, these three dots, by the way, mean therefore. So therefore, this is a proportional relationship. The constant of proportionality is $15 an hour. If we wanted to make an equation out of it, we would simply write something like this. Very, very simple. Next up. Gala apples sell according to the examples below. In this one, we have what looks like 3 different ordered pairs. You could also have had it as a table. We have an x value and a y value in each one of these. And what's interesting about these is that if we were to graph them like I did here, you'll notice that you could use the rise and run technique from each of the points or any combination of points and still get the slope of 2, which is nice. That means it's proportional because the slope stays the same. It also contains the point 0, 0. So we have the point staying the same with the slope of 2. We have the data point 0, 0 being in the graph. We have an equation that we could write y equals 2x. So all of those reasons suggest that that is proportional, right? Piece of cake. Let's keep on going. Starting to get into some things that look like Get More Math. Are the following relationships proportional? And for this, I'm going to go ahead and grab a calculator, although I've done a lot of the work already. We'll have it here if we need it. It says, we're buying gas. It costs this much money for this many gallons of gas. So you'll notice that over here I just did a little division problem. Money divided by gallons. And then I took the other one, money divided by gallons, and I just did it again. Now I'm going to save the calculator work because I've already done it. I divided each one of those. I got 4.34 for the first one and 4.34 for the second one. And because they are the same, we call that constant of proportionality 4.34. And we would say, yes, this is proportional, right? This is proportional because that slope came out to be the same. And the next one down, you're going to see a question like this one on your quiz, on your practice quizzes, and so on. In 4 hours, the depth of water in Shaq's pool increased 32 inches. We're going to take that fact, and we're going to go ahead and say, well, how much is it increasing per hour? So notice how we have here, Shaq is 32 inches in 4 hours. We're going to do a little division, and we're going to figure out that Shaq's pool is increasing in water 8 inches per hour. Let's make a note of that. Now we have this other person. I'll do a different color pen here. Minjun's pool had an initial depth of 2 inches. So they started out with some water in it. After 1 hour, the depth increased to 12 inches. It went from 2 to 12. So look at what we have here. From 2 to 12, it went up 10 inches in the first hour, right? It started with 2, went to 12. Then it says, after 2 hours, that's one more hour on top of this, the depth of the water was 22 inches. So it went from 12 to 22. Okay, so that's still... Oh, look at my notes. That's bad. So let's get rid of this. What I think I see is after 2 hours, the depth was 22 inches. So it went up another 10 inches. So my notes are actually incorrect. You should change those. So this is still 10 inches in the first hour. Which comparison of the two rates of change is correct? So I have two things to compare. I have the Shaq 8 inches per hour, and Minjun is 10 inches per hour. They're not the same, so they're still not proportional. I still agree with my statement there. I just have to scribble out this bottom bit because that doesn't make any sense. And then if you have to choose, it says, which comparison of the two rates of change is correct? Well, here's what we know. They're not proportional because they're not the same, so let's see what we can find. Shaq's pool filled at a higher rate of change, while Shaq filled at 8 compared to Minjun, which is 10, so that is not correct. Minjun's pool filled at a higher rate of change. I think we're going to go ahead and, well, I think we are going to select this one all of a sudden, which means I'm going to get rid of this because that was incorrect. Just to go through the options, Minjun's pool filled at a steady rate equal to the rate that Shaq's pool. It was a steady rate, but it wasn't equal to Shaq's pool. Shaq was 8 and Minjun was 10, so this is out. And Minjun's pool did not increase at a steady rate. That's incorrect. That's what I thought the right answer had been, but that's wrong. I misunderstood that question, so that is an incorrect statement, and you can see the correct one is marked. All right, let's keep going here. This is also the case with decay or loss. This is just the idea of me losing something, losing a pound every 2 weeks. So I have some different examples here. This is just to show that the constant of proportionality can be negative, even though it's still linear and still proportional, right? This is still linear. The line is still straight. We still have the same slope constantly, or same constant of proportionality, and it still goes through the origin, or through 0, 0. We could write this equation y equals negative 1/2 x. Right, so lots of different reasons why this is proportional. And we have some different examples here. And just ideas of this is different ways to write different things that are proportional. All right, final piece. I'm going to go down to the sample questions here and Get More Math. I would suggest if you feel like you don't need this, pause, do the problems, and then come back and I can check my answers. If you need it, then you might want to keep playing the video and doing it with your split screen. So I'm going to jump right in. Which of these tables doesn't show a proportional relationship? So I'll tell you what I'm looking for. I'm looking for a 0, 0 because 0, 0 is a proportional. So I'm going to say 0, 0 is proportional, and anything that's not 0, 0 isn't. Notice how here, this is definitely not 0, 0. Already there's my correct answer. That's all I really need to observe. Now let's move on. Which of these graphs shows a proportional relationship? Shows a proportional relationship. So something I'm looking for is, I'm looking for 0.00. This is 0.00, and the pink line misses it. What's that? This is 0.00, and the pink line just barely misses it. This is 0.00. That pink line is on it for sure. There is my choice. Bottom lower question. Hercules makes $14 per hour delivering newspapers. Lee made so 14. So Hercules is 14 per hour. So I'm going to make a little note of that. And Lee made 44 for delivering newspapers for 44 hours. I'm going to divide that. So $44 divided by 4 is $11 per hour. All right, so they're not the same. That doesn't harm me. It just says which. So then the question, which person has a smaller rate of change? Well, Lee was 11 and Hercules was 14, so I'm going to go ahead and choose Lee. If that's making sense, once again, you might want to pause, go do these problems, then come back. For those who need it, I'm going to walk you through the rest of these. You watch as much as you need until you feel like you can pause and go off and do these on your own. Then come back and check your work. Upper left-hand corner, which of these equations shows a proportional relationship? This is the only one that's written in the format that I'm expecting. It doesn't have an extra +1 or +5 or +4 in the end, so this one is proportional, nice and simple. Easy to identify. It's also the only one where 0 on one side and 0 on the other makes a true statement, because 0 equals 3 times 0. So this one would contain the 0.00. If I looked at the one above it, for example, put a 0 in this one, -2 times 0 plus 4. On the left-hand side, I would get a 0. On the right-hand side, I would get -2 times 0, 0, plus 4, and I would get this statement. And this is incorrect, right? So this one does not contain 0.00 because that does not work. All the more reason to choose the bottom. Next up, which situation represents a proportional relationship? I'm trying to think of all my different options. I want to contain 0, 0. I want y divided by x to be the slope. Let's see what we can find here. First one, a fence already has 9. So I'm already going to identify this is, it's kind of like a +9 in an equation. It's a starting number that's not 0. So that's more like 0, 9, not 0, 0. So I'm going to go ahead and say no to that one right off the bat. If you see a starting value other than 0, it is not proportional. Next one down, the cost of purchasing a basket of oranges is $3.90 per pound. There's no other information. That feels like a nice simple equation. It's $3.90 per pound. That one looks like the one I'm going to choose. I'll read the other ones just in case. Nguyen has saved that much for college and saves $50 every month to add to that amount. It sounds like you have a starting amount, so no. Sid begins with 90. No, he's starting with something other than 0. So we were correct in choosing the second one. Let's keep it going. Ray is running 3 miles per hour. She currently has run none. Okay, that's proportional because you haven't done anything yet, so it contains 0, 0. The equation would be y equals 3x. Which statement best describes Ray's situation? First one, Ray's situation is not proportional. That's incorrect. Not proportional, no. It is proportional. Ray's situation is proportional because she is running 3 more each hour and started with none. Correct. That is 100% correct. Let's look at the other ones just to make sure. Ray's situation is proportional because she will be running at a constant rate. Yes, she's going to be running 3 miles per hour, but she started with 8 miles. There's no information about starting with 8 miles, so we're going to get rid of that one. And then this one says non-proportional, and we disagree. So there we go. Keep it going. Pocahontas driving 2 miles per hour. She's currently driven none. Okay, so that's proportional. We can make an equation. This is just like the last one. This one says non-proportional, so no. If I go down through my choices, this one says non-proportional, so no. So it's between the middle two. Pocahontas' situation is proportional because she will be driving miles at a constant rate? Yes. And she started with 10 miles? No. So this one's incorrect. This is wrong because of the start with 10 miles, which doesn't comment on. So there we go. Let's keep going. The price for 1 pound of oranges at the grocery store is 93 cents. What's the constant of proportionality that relates the cost in dollars to? So this is just a lot of math work right here, a lot of mathy phrasing. All we're talking about is it's 93 cents for 1 pound of oranges. And anytime we have per one, that's what's called unit rate. So you would just type in 0.93. That's your correct answer. 0 would be in front of it. That would be okay too. That is your unit rate. Or your or your constant of proportionality. Let's see, it costs $60.45 to fill up 15-gallon gas. Okay, so this one I want to divide out. So I'm going to take my $60.45 and I'm going to divide it by 15 to see how much per gallon. So $60.45 divided by 15. All right, so I have 403. I'm just going to write 403 up here. And then I'm going to do the same thing with 806 and 2. 806 divided by 2. And I get exactly the same thing. All right, that's a good sign. That means the constant, so I have y equals 4.03x. And it says, what is the constant of proportionality? That means what's the slope? 4.03. All right, 3 more to go. And then we should be done with this video. Bubba is running with friends. He runs 20 kilometers in 2 hours. So he's running, let's see, 20 divided by 2 is 10 kilometers per hour. Notice how I'm always trying to get down to one item, like $1 or 1 gallon or 1 hour. I want to get a unit rate. So sometimes I'll use, not sometimes, I'll use division for that, 20 divided by 2. So 10 kilometers per hour, what's the constant of proportionality? There, 10, piece of cake. Ivy makes $10 per hour delivering pizza. Kiara made 90 for delivering 9. Okay, so this person's a 10. So Ivy makes 10 per hour. I'll put a $sign on there. And Kiara made 90 for 9. So 90 divided by 9, this isn't going to surprise anyone, is 10. So this is $10 per hour. And which person has the smaller rate of change? They both have the same. So we're going to go ahead and choose this one. If we were looking for smaller, we want the smaller number. And the last one. Here we go again. In 5 hours, the depth, I'm going to get rid of the calculator so I have a little more space. In 5 hours, the depth of the water in Sheila's pool increased by 20 inches. Okay, so 20 inches in 5 hours. You can divide that and get 4 inches per hour. All right, that's Sheila. All right, let's make a note of that. Buffy, different person, so different color. These names are funny. Buffy's pool had an initial depth of 17 inches. After 1 hour, the depth increased to 24 first. 17 to 24, let's see, 18, 19, 20, 21, 22, 23, 24. That looks like 7 inches. So 7 inches in 1 hour. All right, think about comparing that. Sheila was 4 inches in an hour. Buffy is 7 inches in an hour, so we already know that. After 2 hours, the depth was 31. That's another increase of 7, so that doesn't change what Buffy is doing. That's consistent. Which comparison of the two rates of change is correct? All right, so Sheila's pool filled at a higher rate. Sheila was 4, Buffy was 7, so it's not this one. Buffy's pool filled at a higher rate of change. Buffy was 7, Sheila was 4. This must be the right answer. Buffy's pool filled at a steady rate. Yes, but they weren't equal to the other one, so no. And Buffy's pool did not increase at a steady rate. That's incorrect. It was 7 for 2 hours in a row. So that is the essence of proportional. If it seemed easy to you, fantastic. You should be able to get through your Get More Math points pretty quickly, move on to mixed review, and then wait for Tuesday when we do just one more little basic thing, and then we get into the pretty much the end of the unit, which is the hardest thing of the unit. If you're looking for a challenge, it should be happening tomorrow or when I return on Wednesday. Good luck.